Hello, and welcome to 5 Minute Math. Today we are looking at lessons learned from the Algebra 1 2024 STAAR EOC, and will be looking at readiness standards, those that are under 60% mastery on this most recent test, analyze each item, try to find trends, and then finally look for instructional implications. So this is a list of the readiness standards and the mastery of them using the state of Texas itemized statewide analysis report. So our very first standard here is 8.9C. You see we're just a little bit under 40% overall mastery, and it's writing exponential functions. Now, these two items are not necessarily created equal. As you'll notice here, number 19, the first time this was tested, we had 59% of our students get it. And really, we're looking for a 60% threshold. If our students get at least 60%, we're pretty confident that that is, for the most part, well understood. It's when you get below 60%, you start having questions, you start looking to see what possibly could be the confusion for students. So we almost got that 60% of number 19. And so what do we need to do here? Well, we need to remember that our standard form is y equals a times b to the x, right? And our a is our initial amount, and then our b is our rate, whether it be a growth rate or a decay rate. And so we don't have either of those. We just have a table of values. So the first thing we need to do is we need to figure out what is our rate. And how do we decide our rate? Well, we can take 2 points and we can divide them, right? So we can take 72, divide it by the previous point, and that would be 48. Or we can take 108, divide it by the previous point, 72, or we can take 162 and divide it by the previous rate, and that's going to get us, all three of these will get us 1.5. Since we're dealing with fractional form, let's write it as 3 over 2. So you see we've got some options right here, 3 over 2, 3 over 2. Now, this is the rate when x equals 1, but if we want the initial rate, we need this b to go away. How do we get that b to go away? Well, if we raise something times b to the 0, so y equals a times b to the 0, well, b to the 0, that equals 1, which means it's just y equals a. So we need to figure out what is b to the 0. So x is 0, which means we need to go backwards on this graph a little bit. And so we need to set up a proportion, right? We need to say 3/2 equals 48 divided by what, right? We can do some cross multiplication. We can multiply it by the inverse, right? So I'll just put that x right there. And so really what we're doing is if we do cross multiplication, we end up doing 96 equals 3x. So we divide by 3. And what do we get? We get 32. And that is going to be our initial amount. So quite a bit of work. So if our students were able to get all of this, that's pretty good. The answer is C. Now you see number 43, 20% correct. This was the lowest item on the entire test. But look what they give us. Same thing. We need y equals a times b to the x. Well, not so much work. They give you the 500 employees. That's the initial. So that is a given. How much are we starting with? And then the rate is 2%. Now, I still need to calculate this rate. So the rate is 1 plus, and then whatever the rate is. If it's a decay rate, it's going to be slightly less than 1. If it's a growth rate, it's going to be slightly more than 1. In this case, I'm going to say it's 1 plus 0.02. I have to convert the percent to a decimal. So 1.02, and then times that to the x. Now, this is the answer. The problem is not necessarily generating the answer because they gave us all the information, a lot more in 43 than they did in 19. The problem is using the calculator or the equation editor. So most students didn't have difficulty with this, right? You had to hit 500. You had to open up the parentheses. At this point, most of our students were doing okay. Now, here's the interesting thing. If you hit this parentheses again a second time, it's actually going to open up a new parentheses, and that's facing the wrong direction like that. what you need to do instead of this, and on the video for this particular problem, I showed students how to do this, right? You would have to hit that arrow button, get the cursor moving outside. That automatically closes it. So even if you can get it to close, now you got to figure out the exponent. A lot of times we're used to something like this button, y to the x. That's what's typically on calculators. In this case, we need this button right there. That signifies our exponent, and then you've got to hit the x up there. So 20% of the students got this correct, and I 100% believe the problem was using the equation editor, not necessarily understanding, especially since you see both of these side by side, how much more information they give you for 43, and how much calculation we actually had to do for number 19. So only 20% of our students were able to get that. So for number 19, we actually could have intuited the correct position without calculating anything. I showed you how to do it without using any answer choices because we knew it was a growth factor and yet the initial position wasn't in the table. So let's go back and look. If my numbers are getting bigger, right, it's a growth factor, which means that's not going to be there and that's not going to be there because those are less than 1, which means those are decay rates. So I could have chosen between C and D, and if I know that my initial position is x equals 0 and it's not listed, then I can't take 48 because that's when x equals 1. So we really could have gotten to C with just using logic. And if students were able to do that, that's fantastic. Number 43, the most difficult problem is not necessarily the fact that it was in a real world scenario, but was using the equation editor, including we had to include that exponent to x. The parentheses might have tripped some people up. So how do we practice with this? Anytime you see this white text, that is going to be the instructional implications. So we need to have students simply write equations, not simply select them, and that's going to help us generate some analog practice opportunities for the equation editor. If you can get onto Cambium and have the students use this, that's great. But in place of that, we need to be writing equations. The fact that I could intuit the correct answer without doing any calculations on number 19 means I don't need to train my students like this because it only works if you have multiple choice. But what happens if you have a drag and drop, if you've got multiple select, or heaven forbid we have an equation editor? So we need to train our students to generate from scratch, which means paper and pencil. Here's a situation, write me an equation. Next, we're looking at A.6a, also 39.5% overall mastery. It's the bane of our existence in Algebra 1. Domain and range. It seems so simple, yet students struggle so much. So we are looking for the range of this. Now, if students can intuit this, that's great. Probably the simplest thing to do would be to graph it. If they graph it, they're going to get something like way up here. Now, we can intuit one thing. Since it is a negative coefficient before the x squared, right? That's a -1 before the x squared. That means it's going to open downward. It's going to be upside down, which means it's going to have a maximum. So if it has a maximum, the range is going to be less than or equal to something, okay? Which means I don't even necessarily need to graph it. Once again, take a look at it. Greater than, greater than, greater than. If a negative exponent means it flips upside down, that means it has a maximum, and it's going to be less than something. In this case, if you graphed it, you would see that it's going to be less than that 900 right there. So it's way up there. You got to zoom out to see it. But our correct answer is D. Only 34% of our students were able to get this. And so a lot of students struggled. They might not have zoomed out because when we're looking at the 030 or the 060, right, we're really looking at our x-intercepts. And so students might have confused range and the x-intercepts. But really, once again, we didn't need to graph this. We did a little bit better on number 32, but still 45% is still not where we need it to be. And so we've got part of a quadratic function graphed. This one is asking for the domain, whereas the other one is asking for the range. And this is a little bit more standard. So you get part of a function right here, and then you're going to get the domain and the range kind of listed, and you've got to figure out which one it is. So domain goes side to side, right? And so we're looking at -2, and then we're looking at 3, okay? So x is going to be less than or equal to 3, greater than or equal to -2. And so we're looking at D right here, greater than or equal to -2, less than or equal to 3. Obviously, some of our choices are using these y values, the 5 and the 0, right? Or in this case, we got a 5 and -4. That's the minimum and the maximum. So there's a lot of different ways to trip students up. So we had 45% correct on that one. So both items ask for descriptions of inequalities rather than using symbols, consistent with past STAR items. So my shorthand was this. If students are only used to seeing inequalities with symbols, they're not ready for STAR. Because look at both of these, ask students to describe it with words. So as students are working on these problems, they should be writing out the inequalities in words, not simply using symbols. For number 9, more students chose B than chose the correct answer. So B, number 44, or B was 44%. And that's, like I said, the x-intercepts. So we had 44% of our students, for some reason, when they think range, they just chose the x-intercepts. And so that's just a vocabulary thing that we need to work with our students, not just domain and range, but x-intercepts. I think a lot of them are used to y-intercepts because of linear equations, but x-intercepts, solution zeros, whatever you want to call them, might be confusing for students. And then for number 32, right, we had 23% choose A, range, and 24% choose B, the x-intercepts. So we had 23, we had 24, and we had 45. So we're all over the place. The x-intercepts, the range, the actual domain. So what can we do? So every time we graph, we should have them find the domain, find the range, and find the x-intercept. Do all three. That's going to help promote discrimination, which means be able to select between those are three related terms, but they have slight nuance differences. The best way to train them as to recognizing just one in isolation is to do a lot of work with the three together. If we train them in isolation, that is not going to be able to provide them the experience needed to discriminate between one or the other concepts. And then we can flip it. We can give students the range and the direction of the graph, right? Whether it's inverted or not, have them sketch a graph. Can they correctly identify that if it's, all numbers, the range is all numbers less than or equal to 900? Do they know that that is flipped downward, right? We don't even necessarily need to start by giving this to them. That could be a scaffold if we need it. Can they sketch it? Because if they could sketch it, right, then that means they have a deeper understanding than simply plugging everything into the calculator and trying to figure it out that way. Next, we're looking at A.8a. We had 42% overall mastery. And we are solving quadratic equations by factoring, taking square roots, completing the square, applying the quadratic formula. It's all different kinds of options here. So number 18 got us 54%. Okay, so what are the solutions here? So there's a few different ways that we could solve this, and so let's just use the quadratic formula, but we can always factor, we can always complete the square, right? So the quadratic formula, it's on the formula chart, -b plus or minus square roots b squared minus 4ac over 2a. We need to know that this is ax squared plus bx plus c. So we do have it in that standard form. So my negative b is going to be -2, right? Because my b is -2 plus or minus -2 squared minus 4. My a is 3, and then my b is negative, and my c is -5. And all of this is over 2 times 3. So quite a bit of simplifying we need to do. Let's make this a positive 2 plus or minus. What do I have? 4. I have a minus 4 times a minus 5. That's a plus 20. And then I've got a 2. Let's see. Plus 20. And then I've got the 3 right there. So that is a 60. Okay. Plus 60. So hopefully you're seeing that perfect square coming in there. That's a 64. So it's 2 plus or minus square root of 64, right, is 8. Let's get that symbol off. It's just 8 over 6. Okay? So now we're getting down to brass tacks here. So we need to separate this, right? So 2 plus 8 over 6, 2 minus 8 over 6. Well, this is going to be 10/6 or 5/3, or this is going to be a negative 6 over 6 or negative 1. So we see a 5/3, right? We see a negative 1. All right, so there's B. 54% of our students were able to do that. They might not like using the quadratic formula. They might like completing the square factoring. That's fine. Look at 31. 31 only has 30% correct. So here's where we probably should have a red flag if we were a student. This is not in standard form. So something strange is happening here because they give it to us, but it's not necessarily in standard form. We're looking for ax squared plus bx plus c. So if I wanted to, I could do a lot of work to get it back to that form. Or there should be something that make us wonder. I wonder if there's another strategy. And it's this one that we rarely use, the taking square roots. We don't do a lot of practice with this. Now, I've got to do something first. I've got to divide both sides by 5. If I do that, look what I'm left with. X plus 3 squared equals 15. Right now, I can take the square root of both sides. That's just going to give me x plus 3. And then I'm going to get the square root of 15. Right, we'll go ahead and put that plus or minus there because it can be either way if we take that square root. And then I need to simply subtract 3 from both sides. I get x equals minus 3, or negative 3, plus or minus square root of 15. And so our answer there is D, but look, only 30% of our students were able to get that. Probably because they didn't see this as a fourth valid option. So we definitely need to practice that way of solving quadratic equations. So they were fairly successful on the first item, number 18, pretty straightforward. Number 31, I showed you the best way to solve that, dividing both sides by 5 and then taking the square root of each. So look at this. For 31, 27% of students chose A, 25 chose B. So when you get 27%, 25%, you get 30%, right? And C is just what's left over. That's a lot of guessing. So really, there's a lot of students within this 30% that probably guessed that don't have the correct answer. And so that gives us a big warning that the students just didn't necessarily understand what to do this. When you see all the incorrect answer choices, their percentages are close to the correct answer choice. So we need definitely more practice with less used methods for solving quadratics, such as the square root, taking the square root. And number 31 could have been solved by distributing out the expression, making one side equal to 0, factoring using any method if you wanted to do that, but that would have been quite a bit of work. But you could have really forced that, if you wanted to, into the standard form. If you distribute out that, if you square this and then you distribute it out and all that business. But that's just a lot of extra work. So even though it could technically be done, I think that might be a teaching opportunity for students. Do all that work for them, show them how long it takes to get it back into this standard form, and then show them the easier way. And they will love this easier way of just taking the square root. They just need to be given enough practice opportunities to be able to recognize when that is appropriate. We are looking next at 8.7c. This is 42.5%, standard in reporting category 4, looking at parent and child functions. Now we've got two different problems. They both scored relatively low, 41 and 44%. So let's look at the first one. Number 21, we actually have a visual, but there is a lot happening with this visual. And so our students need to look at a few different things. First, they need to notice that we have a horizontal shift. So we're moving over here. The vertex has moved from 0 over to -3. Now, of these four things that we have going on here, possibly with the A, the B, the C, and the D, three of them are actually going to be used in this particular problem. So this horizontal shift, first students need to know where that lands, and that's going to be right here. The C is going to be this horizontal shift. Here's the challenge for students, though, is it's f of x minus c. So that c represents the horizontal shift. We went -3, so it's going to be f of x minus -3, which ends up being f of x plus 3. So you see we've got a plus 3 right there, but we've got some -3s that are going to mess up some of our students. We have a vertical shift, so it's going to move down 2, and so we've got to get that down from the x-axis down to -2, and that is this one right here, this f of x plus d. So I'm going to take my f of x plus 3 and keep that. I'm going to build onto that. Since it's a plus d, I can just go ahead and put that plus -2, which ends up being a -2, which both of these have. So right now, A and B both look good. What I need to question is what is happening, if anything, with that A term. So this A term comes outside of the F, it acts as a coefficient, and it either stretches or it narrows the graph, depending on if A is greater than 1, what you're going to get is you're going to get a narrowing. And the higher that A, the more narrow it's going to get. If you were to make A 1,000, it would look like a vertical line unless you zoomed in really, really close. But if A is greater than 0 but less than 1, so it's a decimal, then it's going to widen or it's going to stretch. So in this case, what's happening with our child function? Well, it's narrowing a little bit. It used to be kind of big like this, but now it's kind of brought in a little bit. And so we can see that B actually has that 2 as the coefficient. So that is going to be our correct answer. We had to get 2f and then x plus 3 minus 2. 3 of the 4 possible transformations were in number 21. Now, number 29 seems like it's a lot more straightforward simply because we only have one transformation, but there's no visual. So we need to know where this lands. This is that f of x minus c. So what this means is I've got f of x minus c has turned into f of x plus 7.2. So what can I do in this plus 7.2 to get it to transform from the minus c? Well, it's that same thing. It's f of x minus negative, or let's put that right there, 7.2. That's how you would get that plus 7.2 is if you minus a negative, which means it's a negative 7.2 shift. We're moving to the left. It is a horizontal shift, not a vertical shift, so we're going on the x-axis. So our answer here is B. Now, obviously the 7.2 was in all the different positions, positive or negative, so that was going to challenge our students. We actually did worse on 29 than we did on 21. A lot less was happening in 29, only one shift from the parent to the child function, but there was no visual, and so that didn't help. So for number 21, 27% of our students chose A, which makes sense. At least they got the horizontal shift and the vertical shift correct. And they might not have gotten the horizontal shift correct. They might have just guessed. But if they know that that -2 is going to work because the graph drops, then they know that they can't choose C or D. So they might have eliminated it like that. That's fine. But 27% chose A, and it was this A term that they didn't take into account for. They weren't necessarily looking at whether the graph stretches or whether it narrows. They were just looking at the horizontal and the vertical shift. So that was a pretty sizable chunk of students that missed that. And then for number 32, 29, 32% of our students chose C. And so let's look at that. We've got 32% of our students choosing C, and they simply saw the +2 as a positive shift on the y-axis. So they really weren't sure what was going on, which kind of leads me to believe that our students got A or B correct on 21, not because they knew how the horizontal shift worked, but because A or B, you could choose it simply because of what's happening in the vertical shift. Because if you think this is a plus 7.2 gets you a vertical shift on the y-axis, that's 32%, almost the same amount as the correct answer B, 41%. That's not even the correct axis. You're not even sure which direction it's moving. And we didn't account for the x minus c. That plus 7.2 really messed them up. So that lets us know there's a huge misconception on this particular one right here, how it works, which direction it moves, and how it's different than the vertical shift. So the horizontal shift is not intuitive, as I've been saying, because it's an x minus c. And so what we have to do is we've got to account for that negative in there to graph that child function. So some students might have plugged this in, but if you just plug in, x plus 2, right, then you're going to get an expression that's going to be a linear equation, right? You would need to say y equals, and then you would have to square this, because remember, this x squared, right, that's the parent function, and then the child function is going to put that x plus 2 inside that square, but you have to square that. Then, if you did that, you would see a parabola. You would see it opening up, and you would see it shifted 7.2 units to the left. But we have to teach our students to make sure that they square it. And so our students need help practice identifying what happens in this case, A, C, and D. We didn't necessarily use B in this time, but that's also part of the standard, is what happens if you put that multiplier inside, right, the X. And then we need to practice describing changes from equations before graphing them to check their answer. So we can just use words to describe it. We don't have to get calculators out every single time. We can say, all right, so if my parent function is f of x equals x squared, what happens if, and then you set up a whole bunch of child functions, right? And we could use this structure if we want to. We can start with this. We can say g of x equals f of, and then you can say, x plus 7.2, and you just describe. Turn to talk to your neighbor. What's happening there? What happens if we do this? What if we take that 7.2 outside, f of x plus 7.2? If you can describe it verbally, then you're ready for shifting it to the graph, being able to describe it algebraically or graphically with coordinates and whatnot. But there's a lot we can do before we always just get out the calculator and check. For number 6 and number 33, we were looking at A.11b. This is reporting category 1. Did a little bit better, 45.5%. We are simplifying numeric and algebraic expressions. We're using the laws of exponents. You would expect students to do a little bit better with this because you have all your laws of exponents in your reference materials. And so this first one is what messes up a little bit more. Number 6, we got 39% here. So let's take a look at what's going on. So we're going to have to take 1/3 of the whole thing. I think what's really messing us up is this squared. So this squared, 6x squared, is on the outside, which means I need to square everything on the inside. So one way to visualize that would be to distribute that square. So I'll show you that underneath. This would be a good way to distribute this for students and to visualize it for them. I'm going to take this 6 squared, and I can take the x, I'm going to square it. So that's an x squared that I need to square, and then a y, and then square it. Then I'll keep everything else out here without changing it. So I'm just going to square everything separately in here, and that's going to represent what needs to happen first. And a lot of the mistakes that students make are because they're not squaring everything. They're squaring maybe just the variables and not the constant. Okay, so 6 squared is 36. This is an x squared that I need to square. So what happens when I square a square? Well, when you square a square, right, a times m to the n is the same as a, and then you add, or excuse me, you multiply the exponents. In this case, it would be the same thing, simply because it's 2 and 2. 2 times 2 is 4, 2 plus 2 is 4. But we're going to multiply our exponents here, and this ends up being as a y squared. And honestly, I can just take the parentheses off here, because now I can group like terms, all right? So I've got my constants. So let's take my constants together, and I'm going to bring them together. I'm going to say 1/3 times 36 times, I've got a 2. Just going to rearrange it, okay? Now I'm going to put my x's together. X to the 4th, then I've got x to the 3rd, and my y's together. Y squared plus, or times that y 4th. So what happens there? Well, we're going to take a times n, or a to the m, n to the n. What we end up doing is we add the exponents. So 1/3 times 36 is 12. 12 times 2 is 24. So it's going to be 24. So if I get that, if I could just get that, I've already eliminated 2 answers, right? And what happens is you see where this 4 is coming from for A and C. That's if we're not squaring the 6. 1/3 of 6 is 2. 2 times 2 is 4. So they didn't square that 6. And then I've got my x to the 4th and x to the 3rd. I'm going to add those. It's going to be x to the 7th. And then same with my y to the 2nd, y to the 4th. I'm going to add those. So that is going to be my answer. B. That was only 39% correct. Big difficulty there. Obviously, you see down here on D, you see these incorrect answers. Look at those exponents. The 24 is correct. They just ended up doing the x uh, to the 4th, x to the 3rd. They multiplied that to get 12. Y to the 2nd, y to the 4th. They multiplied that to get 8. So that's that misconception there. Not sure what happens when you're multiplying bases or you're taking bases to exponents. And then 33, same idea, but we do have some division here, right? So that's one thing we're going to need to think about. What happens if we have a times a to the m, a to the n? You end up subtracting. Okay, that's the division of powers. So we're going to need that. We can honestly just separate this into 3 different terms. Okay, 16 over 4, they've got it lined up for us, so we don't really need to move. We're just trying to figure out what's going on with these powers. M to the 7, m to the 14. All right, so 16 divided by 4 is 4. This is going to be a k to the 9 divided by k to the 3. So I'm going to end up subtracting the 2 exponents. So I'm going to get k to the 6, right? And then I'm going to get m to the negative 7, because 7 minus 14, you always have to take the top number minus the bottom number, m to the negative 7. Now that brings in something else. What happens if you have m to the negative 7? Well, a to the negative m equals 1 over, you just actually put it in the denominator, 1 over a to the m. So we're going to end up taking this 4k to the 6, and we can actually just drop that m to the 7 into our denominator. So we got our answer there as B, and we've got, D also had the correct coefficient there, 4. You notice where we get our 3, right? That's 9 divided by 3 rather than 9 minus 3. And this is 14 divided by 7. They did it in the wrong direction. 14 divided by 7 rather than 7 minus 14. So that's where that D comes in. Only 52% of our students got that one correct. So for number 6, I told you that we had some misconceptions there. 25% chose A. So let's go back and look at A. That's 25%. We had the correct exponents. As we said, they didn't square the 6 way back in the beginning. And so their coefficient ended up being only 4, but they did everything else correct. And then we had 23% choose C, and that's where they had, they did neither. They didn't square the 6, and then they ended up multiplying the exponents rather than adding them like you should. So we I mean, 25%, 23%, 39%. There's probably a good chunk of students in that B that guessed it. And so that's definitely one that we need to work on our with our students. And honestly, it's when you multiply not just the power of a power. I think kids can figure this out. If you do this and you take it to the fourth, I think you could use what's on the reference materials and you can figure out that's going to be y to the eighth. You multiply the 2 and the 4. It's this. What happens when you take an entire term like this? It's got multiple things, and then you cube it or you take it to a power. That's obviously the misconception that our students missed right here. So we have to expand what we're taking to the power to use that power of powers rule. And then the confusion for number 6 revolved on when and what to extent to apply that power property and when to apply the product of powers property. When do you multiply? When do you add? What all are you taking? Are you squaring? In that case, taken to the second power. That was the confusion. And then number 33 involved quite a few, but it did not involve the product of powers. And so we didn't have the product of powers confusion versus the power of powers. It was more just the division of powers, and so it ended up being a little bit more straightforward. So having to navigate between an exponent that you take as a power and then exponents that you're simply going to add using the multiplication of powers, that's the navigation our students need to practice with. And so we need to bring these two in together, the product of powers, the power of powers, into the same problem, helps provide discrimination practice so they know which one to apply where. They're very similar, but they do different things when we're dealing with exponents. And then, as they did in this particular problem, the quotient of powers should result in a negative exponent for extra rigor. So they have to apply that extra practice of what do you do when you have a negative exponent? Where does that number actually go? And it didn't do it in this one, but it's also good to sometimes have that negative exponent result in the denominator. And so uh, we end up having to flip that up to the top, and that can sometimes be confusing for students. So that's something else that they didn't ask this time, but it's something we need to keep in mind because that definitely is something that we will see on STAAR. 8.5C, we have 49%. This is reporting category 4. We are solving systems of linear equations. Okay, so number 13 seemed to be pretty straightforward. They don't tell us what to name these, so I'll just do X and Y. Okay, so we're going to have coffee and donuts. My coffee is going to be X. My donuts are going to be Y. Okay, so I'm going to say my first customer, coffee, donuts, X and Y. 4.9 equals 1 cup of coffee, X plus 2 donuts. Just set it up like this. Coffee, X, donuts, Y. So 8.6 is what you paid for. 2X plus 3Y. Now, there's a lot of ways to do this. You can graph it and find the intersection. You can use elimination. You can use substitution. So in this case, I'm going to use elimination. So what I want to do is I just want to double everything up top. Okay, and that's not squared. That's just multiplying by 2. So what I'm going to end up doing is I'm going to get 9.8 equals 2x plus 4y. Let's just subtract. All right, and so what are we going to get there? Well, we're going to end up with negatives, but that's fine because we'll end up with a negative on the left, and we're going to end up with a negative on the right, so we'll end up dealing away with that. So if you end up with a negative uh, over here, typically you'll end up with a negative on the other side, and you get rid of it, right? You subtract that, that's going to go away. 3y minus 4y, you're going to end up with a minus y. So you just multiply both sides by -1, and you end up with y equals 1.2. Now, y was my donuts. I'm looking for my coffee. So I didn't solve for x. I could have done something to solve for the x. I wanted to eliminate the x because I thought that was easy. If I wanted to solve for the x, I'd have to multiply the top and the bottom by something to get the 2y and 3y up to 6y. So I still have to plug this back in. So I'm just going to plug this back into the first one. 4.9 equals x plus, and then I'm going to put the 2 and then the 1.2. So that's going to be 4.9 equals x plus 2.4. And then when you subtract the 2.4 from both sides, you're going to get 2.5, 250. That's what the x equals. So that's our answer A. 60% of our students were able to get this correct. So we have a lot of practice with that. We're doing pretty good with that. It was very straightforward. Number 42 is what really messes us up. So let me show you two different ways to solve this to show you that something should be a little bit off for our kids. So they set it up one with slope-intercept form, one with standard form. So this, to me, says let's use substitution. They've already solved for y, so I'm just going to shove this y into the top equation, and we'll see what happens. So 6x minus 2. Now I'm going to substitute in the 3x minus 5, since they've done all the work for me, equals 10. And let's solve for x. So I need to distribute out that negative 2. So I get 6x minus, that becomes 6x, and that becomes a plus 10. Well, here's my problem. 6x minus 6x eliminates itself. I'm left with a 10 equals 10. All right, so that's weird. So if we don't know what's going on, let's try elimination. Okay, so I need to, let's go ahead and get my 3x over on my left side. All right, so I want to subtract 3x from both sides. Okay, so I'm going to end up with elimination that's going to look like this. 6x minus 2y equals 10. I'm going to subtract the 3x from both sides. I'm going to get minus 3x plus y equals negative 5. All right, so with elimination, I need to get something to be the same. I want to eliminate, let's eliminate the y's this time. So how do I want to eliminate the y's? Well, I want to multiply this bottom part by a negative 2. If I multiply the bottom part by the negative 2, I can make my y into negative 2y, and now I can eliminate. So negative 2 times negative 3x is going to give me 6x. Negative 2 times y is going to give me minus 2y, and that's going to get me 10. You realize I just wrote the same equation twice. So these two are the exact same equation. This is why I got the 10 equals 10. So if I graph the exact same equation twice, what I'm going to get is I'm going to get two lines, if that's our graph, that are 100% on top of each other and aligned with each other. So what does that mean? Well, it doesn't have just one solution. It's got more than one solution. Literally every point to infinity is together, which means it has infinitely many solutions. And that was challenging for our students. Only 38% of them were able to get that correct, and I understand why. So 22% of our students for number 13 chose B. So 22%, and they might have done what I did. They solved for the easiest one to solve for, which in this case they solved for y. They got our 1.2, and they said, hey, that's the answer. Always got to go back and look to see what you solved for. In this case, I solved for the donut, not for the coffee, so I had to do a little bit of extra work to find it. And 22% of our students got tripped up by that. So the answer to a system of solutions being infinite has only been an answer choice once in 2022. And that was not the correct answer. So this is definitely not something that we probably practice with. What happens when you have a system with no solutions? Okay, so that means they're parallel. What happens when you have a system with infinitely many solutions? Do our students know it's the same equation? It's the same line. They're on top of each other. They touch at every single point. Can they describe the difference between these two? Because what we have shown TEA through our work over the last few years is that for the most part, we're getting this, which means they need to up the rigor. And so we're going to go towards these unique permutations of systems of equations where there's no solution, or there's infinitely many solutions, and our students need to be prepared for that. And look at our answer distribution. 14, 23, 24. So let's put that right here. 14, 23, 24, 38. That means we have a whole lot of guessing. There were a few students that actually knew what this was, but there's a big chunk of students in D that got it right, and they don't know it. They just guessed correctly. So when you see answer distributions around 24%, you know there's a lot of guessing going on. So we definitely need a theoretical understanding of infinite solutions. We need to graph it. We need to see what happens. And we need to show them, like I did, multiple methods for recognizing infinite solutions, right? So we eliminated everything when subtracting the equations. We generated equivalent equations. It's a single line when graphed. There's multiple ways to do it, but there should be some red flags for us so that we can help them understand when you have no solutions or when you have a system with infinitely many solutions in addition to your traditional one solution system of equations. Next, we're looking at 8.3D. This is 50% overall mastery. We need to graph solution sets to linear inequalities. So number 12, we actually had the graphing feature on Cambium. And so they just gave us this basic inequality. Now they did give us in slope-intercept form, right? So if we wanted to, we could find our y-intercept there at -2. That would be 1 point. And then we could use the slope of 1/2. So it would be rise over run. So up 1 over 2. We could go right there. That would be our 2 points. That would generate the line. Now then we would need to figure out, is it a dotted line or a solid line? Well, this is greater than or equal to. So that means it's a solid line. So we could just draw that solid line through there. That would be one part. Then we have to click that solution set to get the other part. Once we've got the line on there, we need to click the solution set. We need to click on one side or the other to see which side it's going to be. It's going to be greater than or equal to, so it's going to be above. But if we want to, we can just pick a point, like let's pick 0, 0, plug that in just to make sure. So if y equals 0, greater than or equal to 1/2 times 0, which goes away. So 0 is greater than or equal to -2. So we would just hit that spot above the line since it's greater than, and then that would be our 2 points right there. You notice that we had only 34% get both the line and the shading. 15% got one. 50%, that is a lot of students, got nothing. Absolutely nothing. So next on number 41, we have 64%. So it's a lot easier when you're just selecting from the correct graphs rather than graphing it yourself. So obviously we've got a big area of opportunity here, figuring out how to use the graphing feature on Cambium. Now, this was given to us in standard form, so it's going to be a little bit easier if we just want to find the x and y intercepts, okay? And if we wanted to do that, we would notice that if x is 0, right? 0 plus 2y greater than or equal to 2 divided by 2, right? You get y is greater than or equal to that 1, right? So we've got that y of 1, and you notice that's the same spot on all of these. So all of these actually have the same line. And if we did y at 0, that would be x plus, and then 2 times 0, which is just going to be 0 greater than or equal to 2, so we get x at 2. So that's where we get these points here. The 1 for the y-intercept, the 2 for the x-intercept. So that's really not the problem. The problem here is, what do we do with this greater than or equal to? That's it. So greater than or equal to. Well, first off, it's an equal to, so it's going to be a solid line. We're going to get rid of the b. We're going to get rid of the d. And since it's greater than, we're going to go up above the line. So we're going to go like this. So our answer here is going to be A. Now, once again, if you want to test it, pick something. Let's pick 0, 0. I like 0, 0 because that makes it a lot easier, right? Now that's going to be outside, which means it's not going to work. So that's going to be 0 plus 2 times 0 is greater than 2. So 0 is greater than or equal to 2, which doesn't work. That's why it's outside of our solution set. So our answer there is A. 64%, pretty good percentage we're able to get that. So the inequality for number 12 was given a slope-intercept form. Inequality for number 41, like I said, was standard form. So we need to be able to use both, and there's different strategies for finding points for plotting in either form. Obviously, we struggle much more with our tag-enhanced item than the multiple-choice item. And as I said earlier, this is one in which They do give you 2 bullet points. They tell you right here, but a lot of times we see this, we're not necessarily reading it. To get full credit, you not only need to graph the line, then you need to push the solution set button, and then you need to click either above or below. That's how we get full credit. So just plotting the line like you would on a linear equation only gets you half credit. So we need to graph inequalities by hand to mimic the tech-enhanced items. That's the second best. Obviously, if we get on Cambium and practice itself, that would be great. But if you can graph it by hand, then that's going to mimic them making the choices as to how to find the points, what type of line, and which part above or below you're going to shade in. And then even if you don't necessarily have a practice set, if you can get on and pull on the test and just walk them through the nature of graphing inequalities on Cambium, really highlighting the fact that you need to push the solution set button, that will make sure we're not leaving points on the table. For 8.5a, we had 51% overall mastery for solving linear equations, and they call out the distributive property. So 9 times out of 10, we're going to use that distributive property multiple times. Sometimes we'll have it only on one side, but you see in number 24 and number 46, we have to distribute on both sides. That's really the focus of this standard. So we just need to solve for, and we could plug and play. We could take each of these numbers and put them in there, but let's do it the correct way. So let's distribute. So if I distribute this, right, it's going to be 2/3 m minus 2/3 times 9 equals 1/3 m minus 1/3 times 27. So really I need to figure out what's going on right here. So 2/3 times 9 is going to be 2/3 m minus, that's really a 9 over 1. So if I multiply, it's going to be 18 over 3, which is 6. This is going to be 27 over 3. Let's make that a minus, which is going to be a 9. So I have 2/3 m minus 6 equals 1/3 m minus 9. Well, I want to get my m's together, so let's subtract 1/3 m from both sides. So what I'm going to get here is I'm going to get 1/3 m equals, then I need to get my constants to the other side. I'm going to add 6 to both sides. That's going to get rid of that. So that's going to be minus 3. Now that doesn't help me yet because I want to isolate the m. Typically, the coefficient next to m or x or whatever you're trying to solve for is a whole number and you end up dividing by it. Well, we need to do the reciprocal. So the reciprocal of multiplying by 1/3 would be to multiply by 3 because multiplying by 1/3 is the same as dividing by 3. So that's going to be 3 over 3, which just makes it 1m equals, we got that -9. That's a. So we need to do the same thing here. Now, it's not necessarily fractions, but we do have a term outside, and that 7w is not being distributed. Neither is that 4. So let's rewrite 7w minus, I'm going to distribute the 2, right, minus 2w, and then minus 2, and then I've got that -9. So that -2, -9 is going to end up making a positive 18, right? 4 minus, and then I've got the 8w, and then I've got the minus 8 times the 2, so it's going to be -16. So I can actually bring these two together. 7w minus 2w is going to give me 5w. Minus 2 times -8. 9 is going to be a positive 18. Then I've got a 4, and I'm just going to go and do this. I've got a minus 8 times 2. That's going to be a -16 minus 8w. So really this is going to be a -12 minus 8w. All right, so now I've just got one term of each kind on each side. Let's add 8w to both sides. So that's going to give me 13w. And then let's take 18 away from both sides. It's going to get rid of that. So that's going to give me a -30. So this is what I was saying. Typically, it's something times your variable, so you need to divide by that at the end. That's why this last one right here is going to be probably a little bit tricky for our students because they're used to dividing by that, not necessarily having to multiply by something because you have a fraction there. So it's going to be that 30 over 13, which is wonky, but that is our correct answer. Now, you see we had a lot more difficulty with that 41% than we did with our 24. And honestly, I think the problem here was we had these terms on either side that did not need to be distributed. I think that messed some students up. So obviously, we're using the distributive property that is in our standard. And like I said earlier, we had to distribute on both sides of the equation, not just one. Now, look at number 46. The answer distributions for A, B, and C, 17, 22, and 20. So 17, 22, 20. And the correct answer is only 41. That lets me know there's not necessarily one of the incorrect answer choices that were really distracting our students. We were doing a lot of guessing. And so there was some general confusion on this particular problem for students. And it was that for 24, we had to really think about the use of parentheses here. And simply because we had to figure out that 2/3 multiplying by a fraction, especially the 2/3, even it's a little bit more challenging than the 1/3. That's really going to probably throw a few students off, though in general it seemed like we had a easier time with that one than number 46. So we need more complex equations like 46. We really need to focus on distributing a part of each side of the equation. You see, this is pretty simple. You distribute the whole thing, distribute the whole thing. But now over here, I've got to focus on one part. I got to leave that 7W alone. I got to focus on one part. I need to leave that 4 alone. And that, then I had to simplify afterwards. And I think that's what caused a little bit of confusion. We could obviously use substitution to check their work, which we didn't do in either of these. But if I wanted to, I could plug that negative 30 over 13 back into this equation, and that should give me a true equation. So that would be an easy way, though in this case it would require a little bit of thinking to double check our work, and students should be able to do that on the STAAR test to make sure they get the correct answer. Next, we're looking at A.2i. Now we're up to 52.5% overall mastery. We are writing systems of two linear equations, and we can have a table of values, a graph, and a verbal description. So take a look at number 26, 73%. That is so good. And it is just a verbal description. Hot dogs and bags of popcorn, and they tell you hot dogs are X, popcorn is Y. Okay, so one family paid $8 for 2 hot dogs, 2X, and 3 popcorn. That's not that hard, and the students figured that out. 1650, so 16.5 equals 5 hot dogs, 5x, plus 4 popcorns. Now, obviously, I put the sum that they paid in front because that's the order they gave it to me. You'd have to flip that over on the back side. But we do see everyone had this 8 and 16.5. The challenge was finding the 8 with the 2x and 3y. And there's actually only one. That's the only one we found the 8 with 2x and 3y. You notice D here, we at least were close, but they just flipped the coefficients on the outside. So we have B as our answer. That was not difficult. Number 39 was difficult because we had both. One of them was in the table of values, one of them was in a graph, and we had to use slightly different thinking to find each one. All right, so let's use these 2 points here to calculate the slope, right? We could do point slope form if we want to. There's a few different ways we could do this, but let's just calculate the slope, right? So I'm just going to do my y2 minus y1. So I'm going to say 1 minus -2. And then I'll do my x2 minus x1, 1 minus 0. So that gives me a really easy denominator. Right? So that's going to end up giving me 1. It's going to be a plus. That's going to be 3 over 1. So that's 3. So I'm looking for something with a slope of 3, right? And then if I want to just plug in these values right here, I can say 1 equals 3 times 1 plus b. So then I could say, I'm going to subtract the 3 from both sides. I'm going to say b equals -2. So I've got my slope, m. and I've got my b -2. Now, the way I did it, I still got to do some extra work to get it back in the standard form. Some students are fine with that. Some students would rather just find it straight into that standard form, and that's fine. So I'm going to say y equals 3x minus 2, and then I need to get my 2 over here, so I'm going to add 2 over there, and I'm going to get my y over there, 3x minus y. I don't want to have a negative x, so 3x minus y equals 2, so I see a possibility there, and I see a possibility there. So I'm looking at A or C. Same thing. Now, I don't need to necessarily find the b because they give me the b. Remember, the b is the slope-intercept. It's where the line crosses the y-axis when x equals 0. Well, when x is 0, I know that y is 4. So all I need to do now is find the slope. Okay? So I'll do my y2 minus y1. Let's do the first two. Okay? So 6 minus 4 over -1 minus 0. So that's going to be 2 over -1. So that's -2. So it's going to be my y equals -2x. And then I'm not going to calculate the slope. They gave it to me. Plus 4. Now, I don't want a negative x, so let's bring this -2x over here. So let's do 2x plus y equals 4. And so that's going to give me, remember, I was choosing between A and C, and so I've got my A right there. 2x plus y equals 4. There's a few different ways we could have solved that, but 32% means not a lot of students felt like they had access to that. We had a much more difficult time given a table than a verbal description. Verbal description actually gives you quite a bit of information for students that are used to it because they definitely have to define the variables for you. And for number 39, look at this, more students chose B than chose A. So 34% of our students chose B. So that was extremely close, right? And you see the difference here was the line P, they didn't have a problem. See the 2x plus y, the 2x plus y? The problem was, look at this first equation. So the correct answer was this right here. This 3x minus y equals 2. But remember when I was thinking about how to put it in standard form, I started with this in my slope-intercept form. What would have happened if I would have put the 3x over on the left side, right? I would have had, if I show you like this, if I subtract 3x from both sides, I could have got -3x plus y equals -2. And that wouldn't have worked because you don't want to have a negative x, right? What you could have done is you could have multiplied obviously everything by -1, and then you would have gotten the correct answer. But I think some students were struggling with that, so they just took this and they just kind of ignored this negative. They just thought it went away, and you ended up with a 3x plus y equals -2, which is what they had right there. So some students did a lot of the work. They got this correct slope-intercept form, and then the challenge was, how do I get that 3x with the y? Well, the 3x didn't have to move. Since it's positive, move the y to the right and bring that -2 over to the left. So I think that's an area of opportunity for students is not so much finding the slope-intercept form, how do you successfully put it into standard form while keeping the x positive, because that's what we want to do. And so using two different forms, like the table and graph, generate systems equations had only been asked once before, and not since our STAAR 2.0. We had 59% correct in 2022. So I definitely foresee this being a feature moving forward, is a system of equations, and one is a table of values, one is a graph. Potentially one could be a graph, and one could be a verbal description. But I definitely think the mixed methods is something we need to be looking for moving forward. And we definitely need to focus on the mixed media for writing systems of linear equations, choose the table and a graph. And then rather than working with multiple choice items, we need to be a little bit more generative, right? So rather than selecting from correct answer choices, just hide the answer choices, make them generate them on their own. That always is an easy way to raise the rigor. So for 8.10e, we're up to 54% overall mastery. And we need a factor, trinomials. There's a lot of different ways we can do this. So I'm going to choose one particular method, and you might choose a different method, and that's fine. Students need to have access to all of them, obviously, and find the one that's most useful for them. Now, my favorite way usually is factoring, but when I'm looking at the numbers here, the 6 and the 23 and the 21, I'd rather not. So I'm just going to go with the quadratic formula because we know that always works, right? And so I'm going to get my solutions. Now I am going to have to put that back into factored form. And so x equals, let's just go ahead and put this up here for our visual reference, plus or minus. It's always on our formula chart if we need it. And this is already in our standard form, so I should be able to quickly grab, this is my A is 6, my B is negative 23, and my C is positive 21. So let's do a little bit of substitution here. So I've got my negative 23, right? So it's negative B, and my B is already negative 23, so that's going to end up being a positive 23. And that is going to be a plus or minus B squared. So I'm going to get negative 23 squared, so definitely going to need my calculator, minus 4. And then what is my A? 6. And then my C is 21. Okay, and then I've got that all over 2A, so 2 times 6. So let's just go ahead and put a positive 23 up there. Now, my negative 23 squared is going to get me 529. So I've got 529 minus, and my 6 and my 21 are both positive, so I really am going to subtract this, right? So it's going to be 4 times 6 times 21. That's going to give me 504. So it may seem a lot, but you see what's going to happen there. 529 minus 504, that's going to be 25. We'll be fine. I needed a calculator for those first few ones, but then I don't need a calculator anymore because x is going to equal 23 plus or minus square root of 25, which will be 5 over 12. So let's just look at it this way, okay? 23 plus 5 over 12, or 23 minus 5 over 12, okay? So one option is going to be 28 over 12. Another one is going to be 18 over 12. Now, those are our x's, okay? So we can say that x equals, let's take this first one, x equals 28 over 12. I need to set that equal to 0. So I can say x minus 28 over 12 would be one of my factors. Now, I keep saying 28 over 12. Let's get that a little bit reduced. So this is the same as, let's rewrite this as I can divide top and bottom by 3 here, or 4. So 28 gets divided by 4 7 times, 3 times. Now that doesn't look like any of my answers over here, but that's because what I don't want is I don't want my constant to be a fraction. So I'm just going to multiply uh, both of these terms by the 3, right? And that's going to get me a 3x minus 7, okay? So if I get my 3x minus 7, now I'm looking at that right there. So let's do the same thing with this 18 twelfths. So I can say it's x minus 18 twelfths. Let's simplify that, right? That's actually going to be, if I divide by 6, right, that's going to be x minus 3 over 2. And let's do the same thing. We're just going to multiply that by 2. And we're going to get 2x minus 3. So we're looking at 2x minus 3. And we're looking at 3x minus 7. So I've got both of those there. Now that was a lot of work. Our students might do that. Since we have 4 answer choices to choose from, you know what students might do? They might just plug and play. They might just go ahead and multiply these out. And if they do that, for this particular problem, that works. 68% of them got it correct. So let's just FOIL this out, right? So that's going to be 6x squared, right? Then I've got a minus 9x. And then I've got a minus 14x. Then I've got a plus 21. So that's going to be my minus 23x. Now, if they were to see that, they would see 6x squared minus 23x plus 21. The first answer is it, and that's their choice. So there's many different ways to do this. That is our correct answer, A. Now, 37, you can see it's a lot simpler. Look at my coefficients. It's, x squared plus 7x minus 30, a lot simpler. But I can't take that shortcut. That's what makes me think a lot of our students took the shortcut. They just multiplied these and FOILed them out because I just need one factor here. So I've got to actually do something. I've done the quadratic equation before. This time, let's do factoring, okay? So I am looking for two numbers, right? If I'm looking at a times c, that multiply to a times c, in this case, negative 30, and add up to b, in this case, which is 7, okay? So then I'm going to look at my factors to get me to 30, and since it's going to have a negative product and a positive sum, I'm going to need one of the factors to be negative, but it's going to have to be the smaller one. So, right, so I've got negative 1 and 30. That gets me to negative 29. I've got negative 2 and 15. That gets me negative 13. Negative 3 and 10. That's it. Okay? So uh, I'm going to get my negative 3, and I'm going to get my 10, right? And so those are going to be my factors. I've got my x minus 3, x plus 10. We're keeping the signs that we see there. If we want to go and double check that, that's going to be x squared minus 3x plus 10x minus 30, which gets me back to what I wanted to. And I see an x minus 3. I do not see an x plus 10. I see an x minus 10. Only 40% of our students were able to get that correct. So that was a lot more challenging because you couldn't just kind of plug and play there. For number 16, as I said, they could solve it without factoring. All you had to do is FOIL it out. Couldn't do that for number 37. And look, we had 26% of our students choose B, which, like I said, they probably saw the 10 and the 3 as being uh, two good choices to get us up to 30 with multiplication and get us to 7 with addition, but obviously we've got the incorrect sign there. So when we are working with students, let's remove the answer choices. Let's not give them the easy out of using the distributive property foiling to find the correct answer. And then they need to have multiple methods, factoring, quadratic formula, completing the square. They all work. They need to have the flexibility because one of them is going to be easier for them, and we want to give them choices. Next, we are looking at 8.3b. This is 55.5% overall mastery. We are calculating the rate of change in linear functions. So you'll see number 7, which is a traditional multiple choice. Number 30, we had inline choice. And honestly, we did better on the inline choice number 30 than number 7. So let's take a look at it. The graph of a line is represented by the equation. All right, we got just a standard form equation. Which value represents the rate of change of y with respect to x? I really think part of the issue with students here was this was phrased so formally. The rate of change with y with respect to x. Well, when we're thinking of y with respect to x, we're thinking of y over x, right? Or the rate of change of y over the change of x. So hopefully we're thinking, oh, that's m, that's the slope, right? And so how do we calculate the slope? Well, normally it would be the coefficient in front of the x, but that's only if it's in slope-intercept form. So now I need to take my equation here, and I need to convert, like many problems in this test asks us to do, from one form of a linear equation to another. So I want the y to be by itself, and I want it to be positive. So I'm actually going to add 8y here to both sides. So I'm going to get 5x equals 8y plus 40. And then I'm going to take that 40 from both sides. So it's 5x minus 40 equals 8y. Right now we need to divide by 8, and I can just do it like that, but that ends up distributing out to 5/8 x minus 40 over 8 is just 5 equals y. I'm just interested in this 5/8 x. You see there's all kinds of 8s and 5s, positive or negative. So only 43% of our students were able to get that correctly. We have a statement to complete on number 30, and I put the answer choices underneath. And so this is a real world situation with a table, and we should hopefully notice that we are dropping here, right? So we're going from 25,500 to 2,250 to 12,000. Okay, so we are decreasing. So that's our first choice there that we need to select. And then we need the rate. Well, let's just find the difference between these two. Remember, the rate is the change in y over the change in x. So the y is going to be the 25,500 minus the 20,250. So that's going to be 5,250. That's the difference there between those two. And then I need the difference there, right? That's going to be the 1.5 minus 3.25. You're going to get a negative, and that's where we get the descending because it's going to be a negative. So negative 1.75. So we're using the calculator on this. Obviously, we're going to divide 5,250 by negative 1.75. And what we're going to get is going to be those four answer choices down there. It's going to be one of those. You see those provided for us, the 2,000, 3,000, 5,250, and 8,250. And so this one is actually just a very simple minus 3,000. So we will simply interpret that as decreases at 3,000 feet per minute. We would get the same thing if we were to calculate the difference between those two x's and those two y's. And so that one we had 43% full credit, 47% partial credit. We don't know which item was easier than the other, but I would assume that most of the students probably got this one correct and probably maybe struggled with this, just calculating basic rate of change, change in y over change in x. But if you take those together, you're looking at about 68% overall mastery when you take half of the partial credit and add that to the full credit, which means that one wasn't really the challenge. It was number 7, and that was most likely because of the way it asked. So that formal mathematical language, we need to include that because that might have thrown some students off. And then for number 7, 30% of the students chose B. So let's go back and look. And remember, one of the challenges we faced with previous problems was when we're choosing this standard form that we need to change into slope-intercept form. And if our y happens to have a negative coefficient, what do we do with that y? Because we're so used to just subtracting that 5x from both sides. But if we subtract the 5x from both sides here, we're going to end up with a negative 8y. We're going to have to do something with that. And so that's probably a challenge for some students because they ended up with the correct answer. They just had the sign error. So we need to provide our students plenty of opportunities of getting uh, getting that negative 8y out to the other side and realizing you don't always have to move the x if that's not going to be the easiest way for you. And then obviously our inline choice was a lot easier for students. So we need to reacquaint them with the formal language, right? The change in y with respect to the change in x for our rate of change. And we need extra practice from standard to slope-intercept form. And let's have a lot of different signs of coefficients. Let's make them both negative, both positive, one negative, one positive, in front of the x and the y, just so they can practice and see what happens. And let's also practice describing the rate of change in words. Have them simply describing it. What does that rate mean? And can they describe it in words rather than simply with an expression? Because if we can explain it with words, then we're going to be a little bit better getting ready for these more formal descriptions that we will need to access on the STAAR test. Next, we're looking at A.3c, 56.5% overall mastery, so we almost hit that 60% threshold. We're graphing linear functions, and you can tell the difference. Number 22, 35%, 50, 78%. But this standard is always one that throws us off because look at this, graph linear functions. Okay, this is simply graphing linear functions. This one is hard because now we have the graphing feature. But look at this other one. Identify key features, including x-intercept, y-intercept, zero, slope. That's what that one is. We don't have any problem identifying key features. Let's just get 50 out of the way. What is the y-intercept? Yeah, 78% of our students got that, -2. So we're able to calculate y-intercept or recognize y-intercept on a graph. That's not hard. What's hard is graphing linear functions. If it were in slope-intercept form, maybe, but this is in standard form. So we've got options, okay? So I'll do this two different ways because we need to provide our students options, let them know they can choose which one works for them. We can always solve for y. So let's take 2x plus 3y equals 6. Let's solve for y. I'm going to move the x here because my y is going to be positive. We always need our y to be positive. So it's going to be 3y equals negative 2x plus 6 divided by 3. So you're going to get y equals negative 2/3 x plus 2. All right, so plus 2 lets me know that is my intercept right there. And I need a negative 2/3 x, so it's going to be going down 2 and then over 3. 1, 2, 3. All right, so these are my two spots. All right, so my line is going to be, let's see, let's get one more up. 2 over 3. Yeah, something like this. All right, so changing it into slope-intercept form gives you 1 point, the y-intercept, and the slope, and you can calculate. Another way to do that is, since it's in standard form and you just need 2 points, you could just set each to 0, right? So let's take this, 2x plus 3y equals 6. Okay, so if x is 0, let's see what my y value is going to be. So 2 times 0 plus 3y equals 6, so that obviously cancels out. 3y equals 6 divided by 3, you get y equals 2. So if x is 0, y is 2. Well, same point, but that's just a different way of accessing it. Now, I need a second point. Let's make y equals 0. Okay, so let's do it again. So we will do 2x plus 3y equals 6. And I want my y to be 0. So I'm going to be 2x plus 3 times 0 equals 6. So that cancels out. So it's 2x equals 6, or if we divide by 2, right, we're going to get x equals 3. Once again, we've already got that point. So two different ways to calculate this, and so our students should be flexible with using either one, but only 35% of our students got that. It's just a 1-point problem. They either got the line or they didn't, but barely a third of our students were able to graph a simple linear equation if it's in standard form. So the key features was obviously easier than the graphing, and we had to convert the form to slope-intercept form to graph. And we didn't necessarily have to. That's probably the most comfortable, but we could also set everything to zeros. And the slope of 22, if we did convert, was a fraction, not an integer, right? That negative 2/3 always makes it a little bit more challenging when you have to interpret the negative and figure out, make sure you remember it's rise over run. So the 2 is the vertical, the 3 is the horizontal shift. So we just need a graph, and we need to spend a lot of time converting from standard to slope-intercept form. But graphing with paper, that's going to be the closest analog way that we can mimic this graphing right here, because this is pretty intuitive for students, but just give them graph paper, give them some linear equations. That's a warm-up. That's what we do every day. 8.2a is going to be our last standard that we're looking at here, 56.5% again, and we're determining domain and range. And so we struggled with number 23, didn't so much struggle with number 49. So this is a real world situation. And so a swimming pool can be rented for $110 per hour. The pool can be rented for either 1 or 2 hours. Okay, so 1 hour, that's 110 bucks. 2 hours, it's 220 bucks. That's it. They give us the cost. It's either 1 hour, it's either 2 hours. Now, the cost in dollars to rent the pool is a function of the number of hours. Okay, so when you say the cost in dollars is a function of, that means that's the f of x. The number of hours the pool is rented, that's your x. Remember, our f of x also serves as our dependent variable, which means this is our range. Think of it as our y. This is our domain. And if we just take the first sentence there, they give us the x and the y. 1 hour, 2 hour, 110 each. I'm just going to double that 110 to get my 220. And so we've got it right here. Here's my domain, 1 hour and 2 hours. My range is 110 and 220. For number 49, we're looking at the domain, but it's graphed for us here. Okay, so we've got it 0. And then our domain, remember, we're looking for the x values. Domain is our input values here. So it's going to go to 12. Okay, so our x is going to be greater than or equal to 0. It's a closed dot, so it's going to be less than or equal to, and we'll say 12. We won't say 14. That's just the range that we see, the domain we see listed. And so that is our answer there. 67% of us were able to get that one. So almost as many students chose A, 38%, as the correct answer. So let's go back and look at A. So the problem was not identifying the 1 hour, 2 hour, the 110, the 220. That was pretty obvious. It was just which one is which. Now, technically, they did give us a clue here, but look, once again, it's formal mathematical language. The cost in dollars to rent the pool is a function of. So do we recognize that the dollars is now the f of x? Because the f means function of x. If even we can get this means f of x, that's going to help us at least identify. Most students are familiar with f of x representing the dependent variable and the range. So that is a challenge for students, is recognizing in real world situations which one's domain, which one's range. We can think dependent, independent variable. We can also look to see if they give us clues, even if it's formal geometric language. And then the challenge was obviously differentiating the domain and range, not identifying whether they're discrete or continuous. We didn't really struggle with all real numbers or all integers greater than or equal to 0. We had a few answers there, obviously, but that wasn't the challenge. And then the struggle much less when the data was described graphically. So seeing that graph makes it a lot easier on number 49. And so we need to focus on real world situations, the verbal descriptions, in which they need to be calculated and they're described with words rather than with a table or a graph. And I mentioned them, but let's come back. We did independent and dependent variables in 6th grade. If we can step back for a moment and just do some practice on a problem situation and say, guys, what's the independent variable? What's the dependent variable? Use it logic and reasoning. That will help us because our independent variable is always our x values, our domain. Our dependent variable is always our y values and our range. So we might need to go back to our 6th grade teacher and ask for some lessons that they used on that, and we can bring that back because that's a great way to identify domain and range.